This is the practice assessment for Chapter 3. One of the first things we talked about was transformations on polynomials. They're the same transformations we did in Algebra 2, so we're looking for phrases like up, down, left, right, reflect over x-axis, reflect over y-axis, stretch or shrink vertically, or stretch or shrink horizontally. So in number 1, if the parent function for all three of these is x cubed, what would the transformation be for the first one to become g of x is equal to x plus 4 to the third minus 2? There are only two transformations. This goes to the left 4. Anytime you add or subtract from the input of a function, adding moves it to the left, subtracting moves it to the right. This goes down 2. So anytime you add or subtract from the output of the function, it moves the graph up and down. In part B, there's only one transformation, and it's this 3. The 3 stretches vertically by a factor of 3. The fact that it stretches vertically is very important because if you just say stretches, I don't know if you understand it's vertically or horizontally. So you have to include this word or you don't get full credit for the problem. In part C, the only transformation occurring is that it's going to the right 8. In problem number 2, a soft drink vendor at a ballpark is analyzing his sales record and finds that if he sells X cans of soda in a day, his profit in dollars is modeled by the equation P of X is equal to negative 0.001x squared plus 3x plus 1800. We're going to sketch and label a graph identifying the x-intercepts and the vertex. You can't go and graph this right away. Do not put any scalings on the graph until we have found the x-intercepts, the y-intercept, and the vertex. Now, how are we going to find that? Well, you can play with your calculator for a while until you can find the graph. I tried zoom fit on this problem, and it looked like a straight line. So I had to go and do some more work to get a better idea of what we were going to make our window. So we're working with a quadratic equation. How do you find the x-intercepts of a quadratic? Well, since it has a decimal in it, we're going to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get negative 3 plus or minus the square root of 16.2 all over negative 0.002. Now remember the plus or minus symbol means that there's going to be two solutions. So one of the solutions is going to be negative 3 plus the square root of 16.2. Get an answer and then divide that by negative 0.002 and you're going to find out that one of the solutions is around negative 512. It's approximately because it's a decimal. The other one is going to be negative 3 minus the square root of 16.2. And then I'm going to divide that by negative 0.002. And I'm going to get approximately 3,512. So at least I know where my x-intercepts are. So the window on my calculator, I may make one end negative 600 and the other end 4,000. How did I know to pick those numbers? I picked something just a bit smaller than negative 512 and something a bit bigger than 3512. In order to figure out the window for the y-axis, remember we're not going to work in negative sales here, so you can make your y minimum 0. However, I'd probably leave it at negative 10. But this is the y-intercept. So if the y-intercept is 1800, then we need to see higher than that. But in order to figure out how high I need to see, I might want to find the vertex. So now let's go find the vertex. How do we find the vertex in a quadratic equation? Well, we use x equals negative b over 2a. So negative 3 over 2 times negative 0.001, which was negative 0.002. So negative 3 divided by negative 0.002 was 1,500. So the x-coordinate of the vertex is 1,500. To find the y-coordinate, we're going to plug it back into the original problem in place of x. So negative 0.001 times 1,500 squared plus 3 times 1,500 plus 1,800 is going to give me 4,050. So the vertex is at 1,500 and then 4050. So now I'm going to go back to my window settings because I said, well, how high do I need to see? Well, if the high is 4,050, I need to see higher than that. Maybe I'll make it 5,000. You could make it 4,500. As long as the window you choose, you can see the entire parabola. Remember, we already found the x-intercepts. Now we're going to go draw the graph. And it says label the graph. That's very important. I'm going to be looking for that on the test. So maybe I'll make, I don't know, this will be 1,800. And then negative 512 is going to be closer to y than my 3512. And then my vertex was going to be at 1,500, 4050, which is up here somewhere. So the parabola is going to look, I'm drawing a really bad parabola. Maybe instead, let's try this a different way. Oops. How about I draw the parabola and then I go label my points. There's my 1,500, 4050. This will be, 3512. This will be negative 512. And this will be 1,800. And that's how we're going to draw the graph. Don't draw the graph first. Find the x-intercepts, find the vertex, figure out what window will show you the entire screen, then draw your parabola and label the points. That's probably the best way to do it. And just as a forewarning, the problem that's on the test is not an x squared, it's an x to the fourth. So it won't quite format it the same way as it does here. So you're not going to be using the quadratic formula. However, if you remember that the last number in the polynomial is the y-intercept, and you play with your window, you'll be able to find the graph. Even though it's a fourth degree polynomial, it will be parabolic in shape, and then you're going to be using the maximum function to find the maximum, and you're going to be using either the zero function or the intersect function to find the x-intercepts in order to correctly draw your graph. But the question will be similar in fashion, which is in part B. In part A, it'll ask you to sketch the graph and label the important stuff. The important stuff are the x-intercepts, the maximum, and the y-intercept. And in part B, it'll ask you for some maximum information. It'll ask you where a y-intercept is, except it won't use those words. So in part B, it says what's the maximum profit and how many cans must be sold to obtain the maximum profit. Well, the maximum profit occurs at the maximum. Now you have to know which number represents the number of cans and which number represents the profit. 1,500 is the number of cans and 4050 is the profit. Okay, again, the problem on the test is similar in fashion. You'll use a maximum function, you'll have to find the x-intercepts, but it's not a quadratic and it's not about soft drinks. It's about something else. For number 3, although there's one of them on the practice, there'll be 2 of these on the test. It says, create a sketch, find the x and y intercepts. Identify and find the local extrema and describe the end behavior. That's a lot of questions. Make sure you answer all 4. So this is how I would attack the problem. In order to graph it, I want you to notice that this equation is already in factored form. Although the problem doesn't need to be in factored form to do it, you really can just plug it into your calculator. But the nice thing about this being in factored form is that I know where the x-intercepts are at. I know the x-intercepts are at 0 and 4. And I know that they're both double roots, or multiplicity 2. That means that they're not going to pass through the x-axis at 0 and 4. They're going to bounce off. Now, to get a better idea of what the shape of the graph is going to look like, I'm going to utilize my graphing calculator. I did make a minor change to the window when I originally graphed this. I could tell that it was going to have a W shape, but I couldn't see this part. So I went into the window and I changed the Y maximum to 20. All right, so this is what the graph looks like. Hey, look, the graph seems to bounce off the x-axis at 0 and 4. Not only does it do that, but that means that both of these, they're minimums. So there's a, let's see, A is the sketch, B are the x and y intercepts. The y-intercept appears to be in the same place as the x-intercept, which is 0. So the answer to part B, the x-intercepts are at x equals 0 and 4. The y-intercept is at y equals 0. In part C, it says find and identify any local extrema. So there is a minimum at 0, 0. There's another minimum at 4, 0. And to find the maximum, I'm going to use the maximum function because I don't know where it is right now. So I'm going to do that on my calculator. And it's going to tell me the maximum is at 216. So now I know that there's a maximum at 216. So if I draw this graph, it should look like this. Maybe we'll call this 16 just to give it some scale. There's one thing I have left to do, which is to describe the end behavior. The way end behavior works is we look at the graph as x goes to infinity. That's the right-hand side of the graph. And we look at the graph as x goes to negative infinity, which is the left-hand side of the graph. Well, I want you to notice that both the left and right-hand side of the graph is going up. So in both of these, y is going to infinity. So again, notice how I did this problem. I graphed it in my calculator to help me out. I made sure that I found the maximums and minimums. The minimums, I didn't need to use the minimum function because I knew where they were at, but if you don't, just use the minimum function in your calculator. I labeled everything so that I can grade it easily. If you don't label things A, B, C, D, I'm not sure that you understand that's what you're finding. So in part B, I made sure I labeled my x and y intercepts. In part C, I labeled my minimums and maximums. In part D, I labeled my end behavior, and it needs to be in that format. Not all polynomials have integer answers, so in part 4 we talked about how to find the decimal equivalent solutions of a polynomial, and if you learned how to use the 0 function last year, you are more than welcome to use it. That is not how I do the problem because there is another way, particularly because sometimes the graphing calculator will give you something called a no sign change error. It doesn't like to find zeros where the graph doesn't pass through the x-axis. If it bounces off because there's a multiplicity, the graphing calculator will give you an error message if you use the 0 function. So the best way to do this problem is to graph it in your calculator and make y2 equal to 0. So put this in y1 equals, make y2 equal to 0, and then you get a graph on your calculator that looks something like this. So one of the solutions is clearly at 0. If you look at the table, it'll tell you it's at 0. But the other two solutions are decimals. So instead, I like to use the intersect function, and I just move the cursor close to whatever point of intersection I want to find. And so I can't get quite on that 0, so maybe it'll be above or below. And then I hit enter 3 times, and it tells me that it's at negative 2.24. Oh, it says 3 decimal places. Let's see, 2.236. And then the other point of intersection, the one that's over here, I'm going to move my cursor closer to that 0. And I can't get quite on top of it, but I can get close to it. And it's at positive 2.236. In number 5, determine any vertical and horizontal asymptotes of the function. Vertical asymptotes are places where you have an x value that makes the denominator equal to 0. But before you can determine any asymptotes, you need to make sure that everything is in factor form, because we also have these things called wholes. So in part A, the numerator factors into x plus 2x minus 1, and the denominator is x minus 2. Since nothing cancels, there are no wholes, so the denominator is a vertical asymptote, and the vertical asymptote is at x equals 2. The horizontal asymptote you find by looking at the biggest exponent of x in the numerator and denominator. Since the biggest exponent of x is in the numerator, there is no horizontal asymptote. In part B, the denominator, the only thing I can do is factor out an x squared, but that's really not going to do anything for me. The vertical asymptote, you can have more than one. And so for the vertical asymptotes, you basically set the denominator equals 0. Well, in this case, it's going to be 0 product property. Vertical asymptotes only exist when you're going to have a real number. And I want you to notice that the first equation, x squared equals 0, that means x is 0. But in the second one, I'm going to get a negative under a square root sign, which means it's not real. So there's only one vertical asymptote, and it's at x equals 0. The horizontal asymptote, I want you to notice the biggest exponent of x and the numerator and denominator are the same. That means the horizontal asymptote is the ratio of the coefficients, and it's 5 over 2. In number 6, you can just do these on your calculator if you want. However, for the purpose of this video, I am going to do it the long way. In part A, when you add or subtract complex numbers, you add or subtract the real components. You add or subtract the imaginary components. So 7 minus 5 is 2. And negative 1/2 I minus 3/2 I is negative 4/2 I, which is negative 2I. In part B, when you multiply complex numbers, they distribute like any other binomial, so you would get 12 minus 18i plus 10i minus 15i squared. The last one, the last term, becomes plus 15 because I squared is negative 1. And then I add the real parts, and I add the imaginary parts. To simplify a fraction or a division of complex numbers, you're going to multiply by something called the conjugate of the denominator. And the conjugate of 3 plus 4i is 3 minus 4i. This is where the graphing calculator does come in handy, because now you can just use the calculator to quickly multiply the numerators together and quickly multiply the denominators together. But the purpose of multiplying by the conjugate in the denominator is that the denominator is going to end up being a squared minus b squared, or 9 minus 16i squared, which is 9 plus 16, which is going to be 25. The numerator I would distribute 15 minus 12i minus 3i plus 4i squared. so this is going to become negative 4. This is going to become plus 16. And the numerator is 15 minus 4, which is 11. Negative 12i and negative 3i is negative 15i. And 9 plus 16 is 25. If you do this problem on your calculator, it will give it to you as 11 over 25 minus 15 over 25i. Matter of fact, it probably will reduce this fraction and give it to you as 3 over 5i, which is fine. I don't care as long as it's the right answer. Again, you can just use your calculator to do this problem. Remember, I is the second function above the period. But I'm doing it longhand because I like to practice the distributive. The last part of the test will be on synthetic division, longhand division, and determining if something's going to have a maximum or minimum. I don't know why number 9 is on the test. I didn't write this test, but, you know, to me it's a freebie question. You should all get number 9 right. So I'll just jump to number 9 real fast. It says, by analyzing the equation in its current form, determine if the function will have a maximum or a minimum. This will have a maximum. The reason it'll have a maximum is because it's a negative x squared, which means it's an upside down parabola. But if you aren't sure if it's going to have a maximum or minimum, just graph it and look. If it's an upside down parabola, it has a maximum. If it's a regular parabola, it has a minimum. In part B, I know it's going to have a maximum because it starts with negative, which means that it's going to be an upside down parabola. All right, going back up to number 7, synthetic division. In order to do synthetic division, you're going to set the denominator equals 0 and solve for x, and x will be positive 5. Next to it, you'll put the coefficients from the polynomial in the numerator. Be careful about missing terms. This does not appear to have any missing terms, so it's going to be 3, negative 12, negative 9, and 1. You always drop the first number, and then you multiply by the number in the box. And then you add going down, and then you multiply by the number in the box. Then you add going down, you multiply by the number in the box, and then you add going down, and the quotient is 3x squared plus 3x plus 6 with a remainder of 3. If we write this in this format, we would write the answer as x minus 5, 3x squared plus 3x plus 6, plus 3. I don't think this will happen on the test, but it just so happened that this does have a common factor of 3, so technically I would factor out that 3, but it's not that big of a deal, and again, I don't think it happens on the test. We also need to be able to do longhand division, or the calculus teacher will kill me. And since we would like the calculus teacher not to kill me, I have taught you longhand division. We did do it in Algebra 2. There are circumstances under which we do polynomial division, and you can't use synthetic division. You can only do synthetic division if the divisor is a linear binomial, which this actually is a linear binomial, but negative 1/2 would be the number in your box. When we do longhand division, because there are 2 terms here, we're going to find out how many times it goes into the first 2 terms of the dividend. All you have to do is determine what you have to multiply the first term by to turn it into the first term here. We're going to multiply by 2x squared, and look, I wrote it over the second term. Now I multiply everything in the divisor by 2x squared, and I get 4x to the third plus 2x squared, and then we subtract. This should always cancel. It is coincidence that this also cancels, but I want you to notice that I didn't just write 0. I wrote 0x squared and brought down the next term. That's because the next thing I have to multiply by is going to be 0x. Now I'm going to multiply both terms by 0x, so I get 0x squared plus 0x, and then we're going to subtract. Negative 2x minus 0 is negative 2x. And then I bring down the last term, so this is the last time we're going to do it. I need to multiply my divisor by negative 1. So I get negative 2x minus 1. I subtract these, and negative 3 minus negative 1 is negative 2. So if I go write this in this format, p of x is going to equal 2x plus 1 2x squared minus 1, you don't have to put the 0x, plus negative 2. And that is the Chapter 3 test. Again, there will be more problems on this test than what you see here, but they'll be like, everything that's on here is on the test, but there might be like 2 of the same problem instead of 1.